Hi team, thanks for showing up for your learning. This next kind of question I really like. You want to get very good at this. It should feel like second nature, so I'm asking you to do 8 of them. It's called selecting the form to find the quadratic feature. So you're going to take a look at this problem, and it tells us that there's a function f of x. It's quadratic and it's hidden from view. We must find the x-intercepts and write them as points. We're asked to choose the form that we would like to see to answer the question most efficiently. So just to recall, there are 3 forms of the quadratics that we could have here. There's standard form, which looks like this, all right? And it's very good for finding the y-intercept or the slope as it crosses the y-axis, but I don't think Delta Math is going to ask you about that at all. Then there is factored form. Factored form tells us the roots here and here, but we have to remember that the signs are flipped. Okay, and then there's vertex form here, and vertex form gives us the coordinates of the vertex in the form hk. But h is a sign flipper, k is not. All right. So some of you say x always lies. I don't think so. Math always tells the truth. Not you can make math lie, I guess, but no, x is not lying. It's just because we want this to be 0 if r is a root. So that means x equals r, and r is minus that thing. Okay, so it's just like it makes perfect sense. Don't use tricks to remember these things. Just make sure it makes sense. So in this case, we've been asked to find x-intercepts. X-intercepts, another word for roots. So let's look at factored form. And then we see here that the x-intercepts are going to be, there are 2 of them. I can see 1, 2, and they are going to be the points x is -2, y is 0. Hard to be an x-intercept without y being 0. And -6, y is 0. Okay, so you've probably got the idea at this point. All right. We want to find all intervals where f of x is decreasing. We want to find all the intervals where f of x is decreasing. Let's see if I can take this type of problem out. Actually, no, this one you should be able to do from vertex form. This one is not so bad from vertex form. You don't need calculus here. All right, so yeah, we can just use vertex form. All right, so the vertex form would help us with this most efficiently. Okay, why? We want to find the domains where the value of f of x is going down. It's going to be going up on one side of the vertex and going down on the other side of the vertex, no matter whether it's opening upwards or downwards. Visually, this should make sense. Okay, decreasing means as x increases, y decreases. Vertex form is going to help us do that. So now we see that, and we remember this is a sign flipper. All intervals where f of x is decreasing. Well, this is a problem that opens upwards. All right, so I'm going to show you some rough work here. This is my rough work. I'm going to quickly create a sketch. This is what happens in my mind. I go -2, -48. We'll call that the point -2, -48, whatever. And it's opening upwards. So that means it's a parabola that looks like this. Up until this axis of symmetry here, which goes through the vertex, f of x is always decreasing. After that, it's always increasing. So it's decreasing when x is less than or equal to -2. So we would say x is less than or equal to -2. And I have caps lock on because I like to yell when I type. There we go. Hooray! So vertex form was very effective for showing that, don't you agree? All right, let's do a new one. We must find the y-intercept of f of x and write it in this way. Well, I believe that standard form would be the best for that. The y-intercept is, there are no y-intercepts. There's always a y-intercept unless we've artificially limited the domain or range. There's one y-intercept, and there's always one and only one. If there were ever 2 y-intercepts, it wouldn't be a function because that wouldn't pass vertical line test. All right, so here we go. The y-intercept is at 0 in the x and 48 in the y. It's just that c value. And you can see that's true. F at 0 is 3 times 0 squared minus 30 times 0 plus 48. 48 is the only thing that survives the multiplication by 0. Submit the answer. Yes. Hooray! So those are these problems. Enjoy! And any questions, absolutely hit me up by email. Bye for now.